Hello friends, welcome to my channel Physics for You, and today we are going to learn about phase of resonance. In the last video, in this particular context, we have seen about the resonance and its sharpness. So first of all, we know what is resonance. So resonance is what the phenomena when or the condition when a fundamental frequency of vibration of that body and or we can call it as a natural frequency of vibration of body and the external applied force frequency, when these two frequencies are exactly matches, the body is vibrate with very large, that means the maximum amplitude, and that particular thing condition or that phenomena is known as resonance. And how its sharpness has to be calculated, how its sharpness has to be defined, everything we have seen in the last video. And in the today's video, in context of the resonance, this will be the last video. Here we will talk about phase of resonance. Okay, so first of all, we'll just we'll do some mathematical calculations. If you remember, in case of forced vibrations, we have already seen this equation. Okay, so tan alpha is equal to this equation, whatever I have written here, equation number 1, that is what the phase lead. Here actually this alpha is called as the phase. What is alpha? Alpha is the phase of resonance, or it is also known as phase angle. So considering the phase lead of the force vibration with reference to the driving force, so with respect to the driving force, this was the equation tan alpha is equal to mu p upon k minus mp square. If you remember this equation, we have taken for our simplicity this as equal to a by b. If you remember, we have considered mu p as a and k minus mp square, denominators k minus mp square as b, and from that we have done some calculations, and for that we want a general solution for the force vibration equation. Okay, so among that I will take just this tan alpha term. So tan alpha is equal to this equation number 1, mu p in the denominator minus k minus mp square. You know that this mu is what here actually the frictional constant, it represents the frictional forces. Okay, right. Now let us divide this side or this particular ratio mu p minus mu p divided by k minus mp square, let us divide it by m. Okay, so after dividing by m, what happens to the right hand side only? So after dividing by m to the numerator as well as to the denominator, so here in the numerator m will be in the denominator of mu p, and in the denominator if we divide k minus mp square divided by 2, then m, then this k divided by m as it is, and here this small m and divided by m, here it gets cancelled. That's why k by m minus p square. Okay, why this term we have taken? Because already we have discussed, already we have seen this term k by m minus p square, and we know that a special condition, if this k by m is exactly equal to p square, that is what the resonance condition, or reverse we can say, at resonance this k by m and this p are exactly same. That's why denominator becomes 0, and denominator becomes 0 means this ratio becomes infinity. Then to the left hand side we have tan alpha, so ultimately what we can say, tan alpha becomes infinity. So tan alpha is infinity, so which angle of tan is giving you the infinite value? So obviously it is pi by 2, right? Or we know it is 90 degrees. So tan 90 degree is infinity. So alpha is equal to pi by 2. It means that here this p by omega ratio, right? P by omega ratio is equal to 1 or alpha is equal to pi by 2. Why we have written this? Because if you remember this graph from that article only, resonance and its sharpness. So here we have this central value p by omega is equal to 1, and here it is greater than 1, and here it is less than 1, if you remember, right? And on this axis we have taken the response r. So what we got at p by omega, because we have taken the condition of resonance, so at resonance k by m is equal to p square, and in that case what is p by omega? P by omega is equal to 1, and what we got about the alpha here, it is pi by 2. So at resonance p by omega is equal to 1, and this gives alpha is equal to pi by 2. Okay, have some patience, why we are calculating this you will come to know. And obviously from this graph only we can say, for the lower values or for smaller values of p by omega, then alpha will always less than pi by 2, and for higher values of p by omega which are greater than 1, then the alpha will be always greater than pi by 2. Yes, because we know that this p by omega is moving from here, it is having value 1 and here it is greater than 1 and here it is less than 1. So p by omega either equal to 1, right, less than 1 or greater than 1. So if p by omega is equal to 1, then pi by alpha is equal to pi by 2. If p by omega is greater than 1, then obviously alpha is also greater than pi by 2, and if p by omega is less than 1, then alpha is also less than pi by 2. Okay, now let us draw the graph between p by omega on x axis and alpha along y axis, right. So in the last article we have drawn p by omega on x axis and response r on y axis, but here let us draw on y axis alpha, that is what the phase of resonance. So this will be the graph and its explanation we will explain in short. So yes, what we have to take? We have to take p by omega on x axis and alpha along y axis. Yes, it is taken. Sorry, right. So here, yes, it is p by omega along x axis, and here at this to the right side it is greater than 1, to the left side it will be less than 1, and at this center point it p by omega is equal to exactly 1. Okay, and yes, this axis here we have alpha here along y axis, and this alpha it changes from, yes, pi by 2 at this point pi, and here it is 1. Okay, now if we talk about the frictional forces are absent. For the frictional forces, that means this shape of this curve is also decided by the frictional forces. Not only the resistive forces are are responsible for the shape of this curve, but at the same time we must know about the frictional force, that means moreover the frictional constant mu. So depends on mu, we have these three different curves. So for mu is equal to 0, that means if the frictional forces are absent, then the normal curve will be A, B, C, D, E, because at mu is equal to 0 we know that the resonance will be maximum, and yes, p by omega is equal to 1, and at resonance when mu is equal to 0, at resonance our alpha value will be pi by 2. So this red line curve, that means A, right, or sorry, this one, the curve will go like this. Here it is, I will draw with the black color. So A, right, then B, then again here it is D, A, B, C, D, and here again E. So this will be a straight line curve along this A, B, C, D points. So that is what happening when mu is equal to 0, that means no frictional force, right, no friction, then what is the curve? A, B, C, D, E, right. So here at this point the value of alpha is pi by 2, at point D the value of alpha is pi, and for the larger value of mu, now if let us consider the frictional force is slow by slow increasing, then how it is taking the curve? So this curve too, here it is shown by green color. So this curve too, now it is actually as usual, or already it was a straight line, right, but here as we are moving towards the little bit greater and greater mu values, then what happens? This will be the curve 2, which is shown by green color. That will be the curve of our alpha, that is what the phase. And if we talk about the for lower values of mu, means smaller values of mu, will have the here yellow, sorry, this is blue color curve. So that is curve 1. So along this curve only the value of alpha is changes. So this is what happens when we talk about the value or the curve alpha against p by omega. So p by omega along x axis we have taken as usual, and but along y axis we have taken the phase, that is alpha, and we got these three different curves. When we are talking about the frictional force is completely absent, no friction, that means simply the curve A, B, C, D, E. But for the larger values of mu, we have curve 2, that is shown by green color, and for the smaller values of mu, that means if you are talking about very small frictional forces, then we have the curve that is shown by blue color, and that is curve 1. So this is happens in case of our phase of resonance. So basically phase of resonance means that tan alpha term we have taken, and from that we have derived the value of alpha for a specific case. For a specific case, which specific case we know? We know the resonance case at which k by m is equal to p square, and from this, yes, if you see, yes, from the specific case where this k by m is equal to p square, that case is nothing but our resonance case, and from that we got alpha is equal to pi by 2, and from that we can conclude, yes, if alpha is equal to pi by 2, but it is with one condition, that is k by m is equal to p square, and that is the condition of our resonance. So at resonance we can say, we know already the p by omega value is 1, and here what we got, alpha value is pi by 2, so here it is pi by 2, and along and from that we can conclude, from that we can guess, if the p by omega value is increases, obviously the alpha value will be increases, and if p by omega value is going to be decreased, then alpha value is also going to be decreased. And yes, from these three cases we can draw a graph which is in between p by omega and the phase alpha. So this is all about the phase of a resonance. So very simple and short article, but important one, because from that we can conclude how the resonance is occurring. Yes, the phase only decides how the resonance is occurring, and therefore this one is important when we are dealing with a resonance. So this is all about the resonance, phase of resonance, right? So guys, all things we have seen regarding resonance. What is resonance? Then its sharpness, and today we have seen the phase of resonance. If you have any doubt, you can tell me in the comment box, or otherwise we will stop here, and you please take care and keep learning. If you feel this is value addition to your knowledge, then like this video, and for more such videos subscribe to my channel and press the bell icon so that you will get the notifications as soon as I post the next video, right? So thank you so much. We'll meet in the next video very soon. Thank you.